Now, before we move on to the next module, let's summarize what we've learned in this module. Hypotheses tests and confidence intervals for two means can answer research questions about two populations or two treatments that involve quantitative data. In inference for a difference between population means, we focused on studies that produced two independent samples. We gather one set of measurements from each of these two samples. This is in contrast to the matched pair design, where we gather two sets of measurements from one sample, or there is a natural way to pair individual data samples in one sample with the individual data points in the other sample. The hypotheses for two population means do not involve a variable value. Rather, we test a statement about the relationship between population means. For example, is one mean greater than the other? The null hypothesis, H sub 0, is a statement of no effect or no difference. So we'd say that the difference in the population means is equal to 0 for the null hypothesis. In other words, that the two means are equal. On the other hand, the alternative hypothesis takes the form of one of the following: either that the difference between the two population means is negative or less than 0, or the difference between the two population means is greater than 0 or positive, or that the difference between them is just not equal to 0, which means it could be negative or could be positive. As usual, how we collect the data determines whether we can use it in the inference procedure. We have our usual two requirements for data collection. First, samples must be random in order to remove or minimize bias. Second, samples must be representative of the population in question. We use the two sample hypothesis test when the following conditions are met. First, the two random samples are actually independent. And second, that the variable is normally distributed in both populations. If this is not known, samples of more than 30 will have a difference in sample means that can be modeled adequately by the t-distribution. As we discussed in hypothesis test for a population mean, t-procedures are robust, even when the variable is not normally distributed in the population. Therefore, if checking normality in the population is impossible, then we look at the distribution in the samples. If a histogram or dot plot or box plot of the data in each sample does not show extreme skew or outliers, we take it as a sign that the variable is not heavily skewed in the populations, and we use inference procedures. We use StatCrunch to conduct the hypothesis test for the difference in the two population means. For those who like formulas, we shared the following formulas, but we did not practice using them. From now on, we'll just use StatCrunch in this class for these tedious and complex calculations. With that said, the formulas themselves are not surprising and follow the pattern that we have already noticed previously. The hypothesis test for the null hypothesis is we're claiming that the difference in the two means is 0. For the null hypothesis, it's the sample error divided by the standard error. And the sample error is this numerator here. The observed difference in the sample means subtract hypothesized difference in population means divided by the standard error. But in symbols rather than words, it's this more complicated formula here. Like we said, we're not going to use that, but that's what it would be. And it kind of makes sense, but it's very tedious. Like it said, we might as well use a tool instead of trying to do it by hand.